Hello students, from chapter number 13, surface areas and volumes, we have started solving the sums from exercise 13.1. Today we are going to continue with the same exercise and solve few more sums. So here is question number 7 from exercise 13.1. The question is, the tent is in the shape of a cylinder surmounted by a conical top. If the height and the diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also, find the cost of the canvas of the tent at the rate of rupees 500 per meter square. We are also given a note in the bracket that the base of the tent will not be covered with canvas. So after reading the sum, we could make out that the tent is a combination of two solid figures, and the two solid figures are cylinder and a cone. So when we have to find out surface area of the tent, it is the curved surface area of cone plus the curved surface area of the cylinder, right? So let's quickly draw the figure for the sum and write down the measurements. We are given that the diameter of the cylinder is 4 meter and the height is 2.1 meter. We are also given the slant height of the cone as 2.8 meter. So let's begin with finding the curved surface area of a cone. So diameter of the cone and diameter of the cylinder will be equal, that is equal to 4 centimeter. So radius of the cone is equal to 4 upon 2, that is equal to 2 meter. Slant height is given to us as 2.8 meter. So curved surface area of cone is given by the formula pi r L. So just substitute the values. 22 by 7 into radius is 2 into slant height is 2.8. So cancel 7 and 2.8, that is 0.4. So we are left with 22 into 2 into 0.4, and the multiplication is equal to 17.6 meter square. So the curved surface area of cone is 17.6 meter square. Let's now find out the curved surface area of the cylinder. For that, we will need the radius, which is 2 meter. We will need the height, and the height of the cylinder is given to us as 2.1 meter. So curved surface area of cylinder is equal to 2 pi r h. Let's substitute the values. 2 into 22 by 7 into 2 into 2.1. So this 7 and 2.1 we can cancel. You can cancel that as 7 3s are 21, so it will be 0.3. Or you can do one thing, 2.1 you can convert into decimal fraction. So 2 into 22 into 2 into 21 upon 7 into 10. So the multiplication for the terms in the numerator comes equal to 132 upon 5, because 7 3s are 21 now we have done. So 132 upon 5, and that comes equal to 26.4 meter square. So the curved surface area of the cylinder is equal to 26.4 meter square. Now let's substitute these values in the formula which we have made. The area of the tent is equal to the curved surface area of the cone plus the curved surface area of the cylinder. Substitute the values. We got the areas as 17.6 plus 26.4. If you add it, the addition is equal to 44 meter square. Now the next part of the sum, we are given that the cost of the canvas of the tent for 1 meter square, per meter square they said, that means for 1 meter square the cost is rupees 500. Now how much area we have calculated? 44 meter square. So for 1 meter square the cost is 500. So for 44 meter square the cost is 44 into 500, and that is equal to 22,000 rupees. So the total cost comes equal to 22,000 rupees. Right, children? So the next sum, question number 9. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder as shown in the figure. If the height of the cylinder is 10 cm and its base is of radius 3.5 cm, find the total surface area of the article. This is an important sum, children, and this is asked in the CBSE examination for 2-3 times. Easy but important also. So a wooden article is made by scooping out a hemisphere. So the figure can clearly explain that from the cylinder the hemispherical scoop is taken out from both the ends. What we have to do is we have to find the total surface area of the article. Now the total surface area of the article will be equal to the curved surface area of the cylinder plus, now 2 hemispherical scoops are taken out from the 2 ends. So 2 into curved surface area of hemisphere. So this will be our formula for the total surface area of the article. So let's find out the areas one by one. We will start with curved surface area of cylinder. So we are given the radius as 3.5 cm and the height of the cylinder as 10 cm. So the curved surface area of cylinder is equal to 2 pi RH. I hope, children, the moment I say area of a cylinder or a cone or a hemisphere, quickly the formulas are coming in your mind. And it is very, very important, because if the formula go wrong, then the whole sum will go wrong. So please keep reading and revising and learning the formulas. Okay. So the curved surface area of cylinder is equal to 2 pi RH. Substitute the values. 2 into 22 by 7 into 3.5 into 10. So 2 into 22 by 7 into this 3.5 you convert into decimal fraction. So 35 upon 10, and then you can cancel 10. So 2 into 22 by 7 into 35. Then 7 5s are 35. So we are left with 2 into 22 into 5, and that is equal to 220 centimeter square. So the curved surface area of cylinder is 220 centimeter square. Let's now find out the curved surface area of the hemisphere. That is equal to 2 pi r square. So we'll need the radius, and the radius of the hemisphere is equal to 3.5 centimeter. So 2 pi r square is our formula for the curved surface area of hemisphere. Let's substitute the values. 2 into 22 by 7 into 3.5 the whole square. So we will write 2 into 22 by 7 into 3.5 into 3.5. So 3.5 we will cancel with 7. So 7 into 0.5 is 3.5. So we are left with 2 into 22 into 0.5 into 3.5. So 2 into 22 is 44. So 44 into 0.5 into 3.5. So you will need some time to do the calculations. I hope you all are along with your books and the pen, and you are solving along with me. If you do the calculation, the multiplication comes equal to 77 centimeter square. So we have calculated the curved surface area of one hemisphere, that is 77 centimeter square. We need the surface area for two hemispheres. So let's multiply 77 by 2. So 2 into 77 is equal to 154 centimeter square. So let's substitute the values into the formula which we made. The total surface area of the article is equal to curved surface area of cylinder plus 2 into curved surface area of the hemisphere. So the values are 220 plus 154 and the addition comes equal to 374 centimeter square. Right children? So the sum is simple, but you need to understand that when you have to scoop out the area, we have to scoop out two hemispheres from two ends of the cylinder, how we will make the formula to find out the surface area of the solid figure. So here our sums from exercise 13.1 are over. We will move ahead and go to exercise 13.2, and 13.2 is based on the volumes of the solid figures. So here also we are given the combination of solid figures, and then we have to find out the volumes of the combination of the solid figures. So let's begin with exercise 13.2 and move ahead. Children, in the very first video of this chapter, we have noted all the formulas of surface areas and volumes. So now I want the list of the formulas of volumes of all solid figures in front of you. So this is question number 1, exercise 13.2. The question is, a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. So from the figure we could easily make out that the combination of the solid figure is a cone and a hemisphere. So let's first jot down what all is given to us. We are given that the radii being equal to 1 centimeter for both the solid figures and the height is equal to the radius. Now when we have to find the volume of the solid, our formula will be volume of the solid, or the total volume of the solid, is equal to volume of cone plus volume of hemisphere. So let's calculate one by one. Let's first find out the volume of a cone, and the formula for volume of a cone is equal to 1 by 3 pi r square h. So we need the value of radius, we need the value of height. Radius is 1 and we are given that the radius and height both are equal, so height is also 1 centimeter. So easy, we have to find out the value in terms of pi, so we will not substitute the value of pi there. So 1 by 3 pi into 1 square into 1, that is 1 upon 3 pi centimeter cube or cubic centimeter, because the unit for volume is cubic centimeter or cubic meter. So that is volume of a cone. Let's find out now volume of a hemisphere, and the formula for volume of a hemisphere is 2 by 3 pi r cube, and radius of hemisphere is equal to 1 centimeter. Let's substitute the values. 2 by 3 into pi into radius is 1, its cube is also equal to 1, so 2 by 3 pi. Very simple children, it's just substituting the values and find out the answer, isn't it? Okay, so the total volume of the solid is equal to volume of cone plus volume of hemisphere. We have calculated both the values. Let's substitute that. 1 by 3 pi plus 2 by 3 pi. Since the denominator is same, we'll add the numerator. It's 3 by 3 pi, 3 cancel, so pi centimeter cube. Therefore, the total volume of the solid is pi centimeter cube. Right? So very easy sum. I mean, you just have to substitute the values in the formula and we get the answer. What should be correct is we should be able to identify the combination of the solid figures and recollect the formulas. Alright children, so here is a quiz for you now, and for this I want all of you to be ready with a pen and a book. I'll read the question for you and you just have to write the correct option. And let's see how many answers you get correct. At the end, the answers are also flashing on the slide. So let's go ahead. Question number 1, I'll read the question for you. You have to look for the option and please write the correct option. So first question, diagonal of a cube of length L. So a cube has diagonal L, you have to find out. I mean diagonal you have to find out. Length is given as L. So please select the correct answer. Question number 2. A shuttlecock used for playing badminton has the shape of the combination of. Now bring the shuttlecock in front of your eyes and check out it is a combination of which two solid figures. You have got 4 options in front of you. Quickly read the options and write down the correct option. Right? Third question. The total surface area of the given picture consists of the surface area of which two solid figures? Okay. So find out. I mean the figure is there flashing in front of you. You have to find out it is a combination of which two solid figures. Easy one. So you can, even without looking into the options, you can make out it is a combination of which two solid figures. Your next question is, a cylindrical pencil sharpened at one edge is a combination of, and you are actually writing with pencil, just check out the sharpened edge and the cylindrical pencil. It is a combination of which two solid figures? Please select the correct option. And question number 5 is, during conversion of solid from one shape to other shape, the volume of the new shape will. So check out the answer, whether the volume will increase, whether it will decrease, it will remain the same, or it will become double. You have to select the correct answer and write the option. Now all the 5 options, please check from the answers which are given below. Is that correct? I hope it is correct for all of you because these are all very, very easy and simple questions. So such type of questions are asked for multiple choice questions, and these are easy ones. Now along with this, you have a homework. The question is flashing on the slide. Please check that. For your reference, the answer is also given. You are given a solid figure with combination of, 3 solid figures in that. Identify it and find the total surface area of the solid figure. Alright, so we will stop for today. The next period we will begin with exercise 3.2 once again and start solving the sums based on volume of solid figures. So till then, bye and take care.